All right, guys. So the first part of the class, we are going to cover the quadratic formula. Yesterday in class, we went over how to complete squares in order to solve quadratic equations. For the formula, is basically the formula, has all the steps of completing the squares in it. All right, so I'm going to present you the formula. I'm sure you at least once in your lifetime as a student already encountered this. And we are talking about also equations of the following form. So quadratic equations, they have the following form. There is a number times the variable is squared plus a number times the variable to the first power plus a number, the independent term, no variable in it, and that equals 0. So this is the standard form of the quadratic equation. So in order to solve this, oh, and I forgot to mention one thing, of course, the coefficient A will never be 0 because if it's 0, then it just becomes a linear equation. So it's a different type of equation. So to solve this kind of equation, we can use the formula. So to get an answer means to get a value of x, right? So for the quadratic equation, our discussion before when we were factoring to solve these types of equation was that because the degree of the variable is 2, you are expected to have 2 answers, right? So we're going to have the 2 answers, which sometimes they coincide and then becomes just one single answer, but like repeated the same thing. So in order to find the answer for x, we're going to do minus b, the coefficient b, plus minus square root of the following, b squared minus 4 times a times c. All of this, everything that's on the top of this line, all of that, we divided by 2 times a. Okay, so that's the quadratic formula. We're going to, basically use this formula to solve the examples in the textbook. So in section 24, there are also some applications of the quadratic equations. Okay, so we're going to be using that as well. Okay, I'm gonna put on top of my white paper that you see there, so I don't have to be looking on the side all the time. So it's minus b plus minus square root of b squared minus 4ac. All of this divided by 2, right? So we don't have to be, I don't have to be, moving back and forth between the formula and the paper. All right. So obviously one important thing for using the formula is to identify correctly the coefficients A, B, C. So if you look at example 24.4, in order to solve the quadratic equation that is 6x squared minus 9x minus 7 equals to 0, please note that this is a quadratic equation. And we do have the standard formula, which means one of the sides has to be 0, right? That side there is 0. All right, so identifying the coefficients. So from here, we have that A is positive 6, B is negative 9, and C is negative 7. So we're going to put all these coefficients into the formula and calculate. So the formula is on the top. All right, so let's do this for x. So to find the x, we're going to do minus b, so minus, and then b itself is negative 9. So there is a double minus there. And then this is plus minus square root of b squared, so negative 9 squared, minus 4 times A 6, and times C, which is negative 7. So all of this is inside my square root, and whatever is this calculation, one with the plus, one with the minus, we do have to divide by 2 times A, so 2 times 6. Okay, I have that negative 9 is positive 9, so this is just 9. Plus minus inside the square root, when you follow PEMDAS, the square has priority, so that will be done first. Negative 9 squared is 81, positive 81. And then the next thing would be the multiplication of negative 4 times 6 times 7. So obviously that's going to be a positive number because I have two negatives in that multiplication. So 4 times 6 times 7 is 168. Okay, so it's a plus 168 because I multiply a negative 4 with a negative 7 that makes positive times another positive number is still positive. All right, on a bound is just 12. Okay, so if we add 81 and 168, 249, and then all of that is divided by. Now, all we're going to try to do here is, if I can simplify, I simplify. Unless the problem asks for a decimal approximation, I do not evaluate as a decimal. The factorization of 249 is 3 times 83. None of them are perfect square, so I know I cannot simplify. So I will leave the square root of 249 as it is, okay? So there are two numbers as solution, right? One is 9 plus the square root of 249 divided by 12. Or the other solution comes from the negative sign, so it becomes a subtraction. Okay, so I have two solutions, two real numbers from this. All right. So let's cover also problem 24.5. So it's the same formula, the quadratic formula. We do have an equation that is a quadratic equation, x squared plus 7x equals negative 10. But that is not in the standard form. I don't have a 0, which means my value of C is not negative 10 because I would have to move that first to the other side of my equation. So let's just put this in the standard form. So I'm going to add 10 to both sides of my equation, so I get that 0. So the equation in the standard form is x squared plus 7x plus 10. Like that, I do have the standard form. Now, let's identify the coefficients. So let me choose a different column. There is an invisible one in front of x squared, so that's A, so A is 1. There is a 7 in front of x, so that is B. And there is a 10 without a variable x, so that's a plus 10 there. So C is 10. Let's put this in the formula. So the formula says, let's take negative B, so minus 7, plus minus the square root of B squared, so that's 7 squared, minus 4 times A, which is 1, times C, which is 10. So let me extend a little bit my square root and my fraction. And we're going to divide all this by 2 times A, so 2 times A is 2 times 1. All right? Okay, so x is equals negative 7 plus minus. Inside the square root, if I do the square, that's 49. 7 squared is 49. Negative 4 times 1 times 10 is negative 40, so minus 4. And we divide all of this by 2. All right, so it's still working the number inside the square root. So we have 49 minus 49. So this is negative 7 plus minus square root of 9 divided by 2. Square root of 9 is 3. So this is negative 7 plus minus 3 divided by 2. In this case, because the square root was completely simplified, we have that we can actually do the addition subtraction that is in the formula, the plus minus we have. So let me do that. So the first x comes from plus, so minus 7 plus 3, and we divide it by 2. The second x comes from negative sign in the formula, so minus 7 minus 3 divided by 2. Now we can calculate those because in this time we can actually add and subtract just regular numbers there. So negative 7 plus 3 is positive 4, so we have 4 divided by 2, which is 2. So one solution is 2. The second solution comes from negative 7 minus 3 and divided by 2. So minus 10 divided by 2, negative 5. Okay, so we have two solutions, 2 and negative 5. Before, we didn't do the addition and the subtraction to get the solutions because we did not have like terms, right? So the one with the square root in the answer means I don't have like terms. One is a regular number without any kind of square root attached to that. And the other term of the addition or subtraction has a square root. So we didn't really do the addition subtraction because they are not like terms. But when you can do the addition subtraction, you should, okay, and simplify your answer as much as possible. All right, so problem 24.6, we have 4x squared equals 6x minus 3, okay? Again, the equation is not in the standard form. We're going to, move things around so we get one of the sides to be 0. So I'm going to do that by moving 6x and negative 3 to the left side. So let me subtract 6x on both sides and add 3 on both sides. So I know I have 0 on the right side. Now, none of these on the left are like terms. So I'm just going to arrange, put 4x squared in front, minus 6x, and then plus 3. So coefficient A is 4, coefficient B, negative 6, and coefficient C, positive 3. So in the formula, which is the value of x is given by minus b plus minus square root of b squared minus 4a times c. All of this divided by 2 times a. And we have that minus b is minus negative 6. And then we do plus minus square root of. Now, inside we have b squared, so negative 6 squared. And then that minus 4 times a, which is 4, times c, which is 3. And we divide this by 2 times 4. Okay, so now let's do the operations. Everything is just number, no more dealing with algebraic, manipulation. So we have that x is minus -6, +6. So we have +6 plus minus. The square of -6 is +36. And then we're going to have minus something because as you can see there, we have minus and everything else is positive. So it's a negative sign in that multiplication. So 4 times 3 is 12 and 12 times 4 is 48. So minus 48. All of this divided by 8. Now, if I subtract inside the square root, okay, so -12, and then we have to divide all of this by 8. Now we're going to simplify the square root of -12. We already know from previous classes that anything that is a square root of a negative number becomes a multiple of I. So I'm going to write that -12 as 12 times -1. So because of that, we can split the radical. So we have square root of 12 times square root of -1. And we can simplify square root of 12 because 12 is 4 times 3. Perfect square 4 will completely simplify. And the square root of -1 is I. All right, so here I have 6 plus minus. And again, rewriting 12 now as 4 times 3, and I will split that radical again. And square root of -1 is I. And I still have everything divided by 8. So this is 6 plus minus square root of 4 times square root of 3, I, all divided by 8. And simplifying 4, which is when you take the square root, it's 2. We have 6 plus minus 2 square root of 3, I divided by 8. Okay, so far? Now, there is one extra step that we must take that to simplify completely the answer. The radical is simplified to the maximum, but the fraction, all the numbers can be divided by 2, the coefficient numbers, not inside the root, the coefficients of this fraction. So we have that 6, 2, and 8 all together can be divided by 2. So we are reducing all the numbers by 2, okay? So if you divide 6 by 2, you get 3. So this is 3 plus minus 2 divided by 2 is 1. So I'm not going to write 1. I'm just going to write the rest, which is square root of 3i. And 8 divided by 2 is 4. So now all the requirements for a simplified form of the answer is there. The square root is simplified. The multiple of I, to remove the negative sign from inside, is also simplified. And also, I reduce the fraction to lowest terms by dividing all the coefficients, meaning the numbers outside any kind of root. We divide them all by 2. So that's how I got 3, 1 in front of the square root of 3, and 4 on a bar, okay? We cannot do the addition and subtraction, the plus minus that you see there from the formula, right? Because 3 is not a like term with the square root of 3i. So we're not going to add or subtract. So I still have 2 answers, 2 numbers. They both complex numbers, but I cannot simplify any further. So that these are the solutions we get.